So good morning one and all. We are starting the activity presentation for the subject electric and hybrid vehicles. So first group today who are going to present is from division A and Ethan, Desa and Spurti. They are going to present their work on starting requirements of a vehicle. So I would request Ethan to please start presentation. Thank you.
Okay, so our course activity is the starting requirements of the vehicle that mainly includes the starter motor. So the outline of this presentation will be consisting of the engine starting requirements, starting system design, using a starter motor and a few applications based on the starter motor. So an internal combustion engine requires the following criteria in order to continue running. That's the combustible mixture, compression stroke, and form of ignition, and has to have a starting speed of 100 rpm. In order to produce the first of these, the minimum starting speed must be achieved. This is where the electric starter comes in, and the ability to reach this minimum speed is dependent on all the factors which are given below, that are the rated voltage of the starting system, the lowest possible temperature at which it must be possible to start the engine. That is known as the starting limit temperature, and the engine cracking resistance. That is the torque required to crank the engine at its starting limit temperature. That is inclusive of initial stall torque, the battery characteristics, and the voltage drop between the battery and starter, and the starter to ring gear ratio, and all the characteristics of the starter, as well as the minimum cranking speed of the engine at the starting limit temperature. Starting system design. Uh, this in this it, so just give me a moment, so please. So sorry for the disruption. So I just need a moment for my.
Things are in front of you in the screen. You just explain all those parts.
No, sir. I prepared some notes, some external things. So just, sir, please excuse me, sir, but just give me a minute, sir, please.
First, whatever is given in the screen, that part you explain, and later on you can do some extra thing.
Okay.
So
Okay.
just take cue from the things that is given already. So explain what is meant by long service life and maintenance free and other things. Whatever is given, you explain first, and after that you can add.
Okay, sir. Okay, sir. Will do, sir. Okay, so the starting system of any vehicle must meet a number of criteria that is in excess of long service, that that consists of a long service life, maintenance free, continuous readiness to operate, robust such as to withstand starting forces, vibration, corrosion, and temperature cycles, and the lowest possible size and weight. So in the figure at the side, it is important to determine the minimum cranking speed for the particular engine. This varies considerably with design and the type of engine. The rate of voltage of the system for passenger cars is almost without exception, which is usually 12 volts. But trucks and buses are generally 24 volts, as this allows half the current that would be required with a 21-volt system to produce the same power. It will be considerably to reduce the voltage drop in the wiring, as the length of the wires used on commercial vehicles is often greater than passenger cars. The rated output of the starter system can be determined by the maximum capacity for the starter, which has a 20% drop in capacity at 20 degrees when it is connected to the starter by a cable with resistance of 1 milliohm. These criteria will ensure the starter to operate even under the most adverse conditions. The actual output of the starter is measured by typically by operating conditions. The rated power of the motor corresponding to the power drawn from the battery is drawn from the battery less copper losses due to the resistance of circuit and iron losses, which is by eddy currents induced in the motor and friction losses. So there are two considerations which design a starter system. That is the indication on how the starter output is very much determined by the line resistance and battery internal resistance. The lower the total circuit resistance is the higher the output from the starter. The location of the starter on the engine is usually predetermined, but the position of the battery must be considered. Special arrangements for sealing the the circuit on the starter may be necessary to prevent all contaminants. Usually, this is used in off-road vehicles, and the position of the battery may determine the cable length. If the cable length will be shorter, a longer run will mean cables with a greater cross section are needed to ensure a lower resistance. Choosing the starter motor. A greater torque is required for engines with a lower number of cylinders. This is actually so due to because in an engine, say you have a displacement of 2 liters and you have a 4-cylinder inline 4 engine, and you have a same 2-liter engine which has say 8 cylinders, a V8 engine. So the torque per liter in each cylinder in a higher engine capacity would reduce as the number of cylinders increase. And so also if you take into consideration with the position of the cylinders, say because of the V shape of the engine, it would increase the torque. These are external factors, but anyway, the greater torque is required for engine with a lower number of cylinders due to the greater piston displacement per cylinder. This will determine the peak torque values. The other main factor is compression ratio. Um, so an example on how it would work um, is usually with so now with the same 2-cylinder engine, say the engine requires 480 Newton meters to overcome static friction and 160 Newton meters to maintain the minimum cranking speed. The pinion to gear ratio would be 10 to 1. So the maximum stall torque would then be 48 Newton meters and the driving torque would be 16 Newton meters. The greater torque is required for engines with a lower number of cylinders due to the greater piston displacement per cylinder. So as I mentioned before, due to the as the number of cylinders increase,
Then for
the
us
number
left is also
okay, so uh, the torque is converted in the following equation to obtain uh, cranking torque, which is usually generally 4 to 3 times that is assumed, where P is power, P is torque, and omega is angular velocity. So as can be seen in the graph, so okay, choosing a starter motor. So to choose the starter motor, so usually when when you have say you have a 2 liter engine and you have four, it's an inline four. Now you can have the same 2 liter engine in a different configuration, say a 8 cylinder engine, a V8 engine. So then if the engine cylinders increase with the same volume, the torque decreases the per cylinder if the engine cylinders are more. A greater torque is required for engines with a number of lower cylinders due to the greater
Hmm.
piston displacement per cylinder. This will determine the peak torque values. The other factor is compression ratio. To illustrate the link between torque and power, we can see in the diagram, or we can refer to that later. But centigrade, a four-cylinder 2 liter engine requires 480 Newton meters to overcome static friction and 160 Newton meters to maintain the minimum cranking speed of 100 revolutions per minute. With a starter pinion, uh, with starter pinion to ring gear ratio of 10 to 1, the motor must therefore be able to produce a maximum stall torque of 48 Newton meters and a driving force of 16 Newton meters. This working is based on the assumption that stall torque is generally 3 to 4 times the cranking torque. Greater torque is required for engines with lower number of cylinders due to the greater piston displacement per cylinder. This will determine the peak values. So then that is referring to the displacement per cylinder block. When you have more cylinders, the torque per cylinder decreases as the number of cylinders increase. But so if you
Correct.
have, say,
Yeah.
but per if you say an engine is an inline four, and then you have the same displacement with an 8 cylinder engine, and it has a V shape. So there is a possibility that the torque will not decrease as drastically because of the V shape that when each cylinder fires, it causes a rotationally motion to the other cylinder on the V shape on the other side. So the torque per liter is not decreased as drastically as compared to an inline configuration. And then, so if we talk about torque, how it is converted in power, where you have power, which is P, T, torque, and omega, which is angular velocity, and N, where omega is equal to 2 pi n by 60, where n is the revolutions per minute on how many times the crankshaft moves. In this example, power developed at 1000 rpm with a torque of 8 Newton meters at the starter is about 840 watts. Now looking at the
Correct. You
figure,
can go to
the
the next
ideal
slide. This slide is understood. Please go to the next one.
so the application in Formula One using the starter motor. So in a Formula One car, the electrical starter motor is an external unit, and it is usually held by a mechanic, which features a long probe that is plugged into the back of the gearbox and engages a pair of gears. First, he inserts the probe into the gearbox and then receives a signal to push the starter button. This engine, this turns the engine over and the engine speed and oil pressure. And using a laptop, they will effectively turn the ignition on. So, in terms that I spoke about earlier about buses using 24 volts, so does Formula One cars, and it has a handheld electric motor through a long shaft to start to turn the gearbox through the gearbox to the engine. But the motor sometimes has a kick in it. But usually, if it has like in the olden times, where you used to crank the engine, a kick in the engine would cause severe disruption to the arm. But over here, uh, the reaction arm, which hooks up onto the rear wing or to the road to stop it coming out of the mechanic's hand. So it's safe. He
Fine. Next
starts
one.
the feature. Okay. Okay, so this is a manual starter motor, which was used in before starter motors were created. So when originally the driver had to get out of the car and manually crank the engine, and because the engine would backfire sometimes, there would be a possibility of him also breaking his arm while cranking the engine.
Correct.
The
Correct.
starter the starter motor is the one that replaced the hand crank of the
Fine.
gas engine.
Correct. Correct. Next one, please.
Okay, so and so another application is nowadays, so when electric cars are being used, there is no need of the starter motor at all, and they still do have a small 12-volt car battery which would power the starter directly from the main battery pack, and there is no alternator also used to keep charging the starter motor. Okay, thank you, sir.
Fine. Good. What is the relation between torque and speed and power?
Torque and speed and power. So torque would be the rotational, the pulling powers of the engine,
Yeah.
and
So
the
vehicle power, vehicle speed, and vehicle torque. What is the relation between them?
power.
So vehicle power is equal to,
Power would be the so yes, so the power would be the translational motion. So when the engine fires in the block, in the engine block,
yeah, that is
that
understood.
power
So
so
so you can write it
would be
down.
the
Power is equal to torque into speed. That is the simplest equation we have. We started with. So power is equal to torque
yes,
into speed. Whenever you are in the lower
yes,
gear, at that time torque is more, speed
yes,
is less. And as you are increasing
correct.
the gear, at that time speed increases but torque reduces. So both the things you
Torque
cannot
yes,
increase together. Torque and speed you
yes, sir.
cannot both increase together because power is constant. So there is
The
a
power
important
correct.
equation for all you have to remember. That is power is equal to torque into speed. So one you increase, the other thing decreases. Fine, Ethan, thank you. You can stop your presentation. And next group, Adnan and all, you can start presenting.